Good morning. Today we are going to be talking about distance and time functions. There's a common use for a function. All right. So the idea is that anytime you have a graph, we always put time on the bottom. That means up on the side over here, this would be our distance from home. All right, so looking at where our home is, and home doesn't have to be your house, it's just your starting place, where you originated from. So as you look on the scale across the bottom for time, of course we will start at time 0, and then you're moving in whatever units you want to use. You could be doing seconds, minutes, days, years, centuries. That part could be anything, but again, it's all related to time. Now on the other side, your distance from home, your starting point down here at the bottom is 0, and that would be the location of your home. So anytime your graph is at the bottom, that means you're home. All right, and again, you would be counting in any number of units, miles, feet, yards, anything that could be measured in distance along the side. All right, and the idea is that we could have some different things happening. For example, if you started at home in the bottom and you started to walk away from home, you would have a graph where the line was moving up from left to right. That's called slope, moving in an upward or downward direction. So again, when you're moving upward, it means you're getting farther away from home. All right. Now, at any point in time where you flatten out, all right, the flat part of the graph means you are not getting any farther from home. Right here, you were, two, whatever those units are, two blocks from home, but right here you're still 2 blocks from home. So those areas are areas of no movement. Anytime it's flat, that means there's nothing happening, no movement at all. All right. Again, anytime it's going up, you're moving away from home. All right? And then the opposite would be going down. Anytime you are moving downward, you're headed back toward home. Remember, home is the bottom. Right now, if you make it all the way back to the bottom, like we did here all the way at the end, then you're back home, back where you started. It took you 4.5 minutes to get there, but you're back home. You went to a friend's house, you stayed for a while, and then you came back home. So that's what we can do, is we can tell stories based on what's happening. So again, in this first part over here, this would be you walking to a friend's house. They must live close. It only took you, 1.5 minutes. Then you got to your friend's house and stayed there for a couple of minutes. You needed to talk to them about something. You stayed there for about 2 minutes, and you didn't go any farther away or closer to home. And then this last part here is when you were heading back to home, making it back to your house less than 5 minutes after you started. So again, you can make up stories to these, and that's the idea. Over the next few days, we want to see if we can kind of tell a story with a distance and time function graph. All right, here's another one. It's a little bit blurry, but again, you can still see the same idea. All right, so again, right here at the beginning, that's where you're home. And it says Tom starts from home. All right, then as he moves here, that line is up pretty steep. The steeper the line, the faster he is moving. So again, a steep line is fast moving. That means you are going somewhere quickly. Maybe you're running. And then at a certain point later on, it looks like you slow down. You're still moving. You're not flat. You're still moving, except for this time you've slowed down. That's what you can see there if you can read that. Again, it's a little bit blurry. Sorry about that, but I liked the picture. All right. Now, at a certain point, right here, when the direction changes, now no longer going up, now we're going down. That's the place where Tom has turned around. He's the farthest he is away from home. Again, I know that he's the farthest away from home because that is the highest point on the graph. If I look over, again, when distance from home, that's the farthest away he was. So that's how I know that that was the farthest Tom got from his home. But again, That red portion there, that's him heading back home at the same speed the whole time because the line is straight. And when the line changes, like from the green and the blue over here on the left, that means his speed has changed. He's still walking away from home, but the blue part's faster because it's going up more quickly. Where the green part, he's moving slower because it's a little more flat. If it was all the way flat, he'd be stopped. So the closer you are to flat, the slower you're moving. The farther away you are from being flat, the faster you're moving. So it looks like that red part, he's moving pretty fast, headed back towards home. All right, so your assignment today is to just kind of get used to how this stuff starts at the beginning. All right, so we have a table, and this is what your work is. I'm going to go ahead and start your assignment for you today, and then have you finish it on your own. It says, what does the graph tell you about a trip that Robert took? Use the graph to complete the table. So in this one, a little bit different than the ones we just looked at, he is not starting at home. He's already, looks like 180 miles from home, almost, when he starts. So he must have been visiting someone. And at the very end, that's where he's returned home. And it looks like that's 6 hours. So he must have been far away and driving in a car. All right, so let's look at how to fill out the table. So at time zero is right here at the origin, the beginning. Distance from home. And we're going to just go ahead and make an estimate. Looks like it says about 160. So just go with the closest. It doesn't have to be perfect. All right, anywhere in that zone. Then change in distance from last time. Well, there was no last time, so there's no change. None. Then time since last change. Well, again, there was none. This was the very beginning, time zero. All right, now let's look at time 1. So at 1 second. That means I'm right up here on the graph. All right, so at 1 second, his distance from home is still 160. How much did that change from the last time? Well, it changed 0. It didn't go up or down. How about the time change since the last one? Well, it has been 1 hour. So again, just trying to get used to reading this type of graph. Tomorrow we're going to work on the whole idea of stories behind it. So that's your job today. So let's do one more to make sure you know what's going on. All right, so at 2, that's right here on the graph. So with that dot right there, the distance from home looks like now it's down closer to 80. Change in distance from last time, well, that has gone down 80 from the last time, 160 minus 80. And how about the time change? Well, again, it's been 1 hour since the last time we made a dot. Now be careful, some of these other ones have decimals in them, so be careful on them, but the work is still somewhat relatively simple. All right, your job is to finish this table out today. Good luck.